Hey everyone, welcome to another episode of DevOps with Zach. Meet our guest, Carlo, a chemical engineer and a beer brewer. After falling in love with tech, he made the leap of faith to pursue a career in IT. He works primarily in cloud native, containers, and DevOps space. Let's get started. Hey Carlo, welcome to my podcast, DevOps with Zach. And thank you so much for your time and really appreciate your joining with me today to another episode of DevOps with Zach. I'm sure we're going to have really some time. And yeah, welcome.
Thank you. Thanks for having me. I'm doing well. Thank you. I went for a run this morning, so get that blood pumping.
Oh, that's good. I might go later today because it's a whole day here. Yeah, it's a lovely day outside, right?
Yeah, and I'm doing the round the base on Sunday, so I'm trying to get ready for that.
Oh, that's amazing. I think I forgot to register for that. That's no mind. It's all good. Cool. So today we are going to talk about a very interesting topic. And we all know Kubernetes containers is a very hot topic these days. Everyone talking about
Mhm.
it. But we are going to talk about a specific area in Kubernetes, especially when it comes to scaling. So we all know that currently we have HPA, horizontal pod autoscaler, but I know there are some limitations and pros and cons. Let's talk about current limitations of horizontal pod autoscaler.
Yeah, sure thing. Kubernetes natively offers the horizontal pod autoscaler, or HPA for short, as a controller to increase and decrease replicas based on demand. While this is enough for most workloads, there are limitations to it. So I'll just lay out these limitations. First one, it cannot scale to zero. HPA by default uses metrics, namely CPU and memory utilization, to calculate the desired number of replicas. Now, these metrics cannot be zero. So this means that the desired number of replicas cannot be zero as well. And obviously, this is not ideal for intermittent and resource intensive workloads when you're trying to optimize something. Secondly, it's limited to scaling based on metrics. Originally, HPI only provided the ability to scale on pods metrics, namely CPU and memory, as mentioned earlier. However, as of V2, which has become stable as of Kubernetes version 1.23, it can now support custom metrics exposed using metrics APIs, such as the metrics server. However, as mentioned, it doesn't support scaling based on events, queue length, or HTTP traffic. Now, I'm not really privy to the plans of the Kubernetes autoscaling SIG, but so far I haven't seen any indication if this will be supported in the future. Third limitation for HPA is that it's dependent on metrics aggregators. In order for HPA to work, it needs to fetch metrics from aggregated APIs. Now, these APIs are usually provided by other add-ons that you have to install on top of the cluster separately as an add-on. Examples of these are metric server or Prometheus adapter that exposes Prometheus metrics. And last limitation, or the fourth limitation that I'm gonna lay out for HPA, is that it often does not scale on the actual target value. HPA bases its scaling decisions on target metric value. However, due to how the HPA scaling algorithm works, the current target value on the HPA that often does not match the real-time metrics of the system you're scaling on. So these are the limitations for HPA.
Yeah, cool. So we have multiple tools, especially when we're talking about the CNCF landscape, right? We can see there are so many tools available in the industry.
Hmm.
You think of any specific tool that which can be rectify these limitations?
Yeah, one of the tools that has been gaining popularity quite recently and over the years is a tool called KEDA, or Kubernetes Event-driven Autoscaling. It is under CNCF and it has a big community backing.
Cool. So why KEDA and how it can solve the existing issues in current scaling in Kubernetes?
Yeah, that's a good question. So, for us, as our clusters grow, there's also a demand for hosting various workloads with different scaling requirements. So in our case, we want to be able to scale on metrics not only inside but also outside of the clusters, such as from Amazon Managed Prometheus or AWS CloudWatch, Kafka, or any other event source. HPA, with its limitations, as I mentioned earlier, is clearly not cutting it. So, a bit of a history around this. For around 6 years ago, there was a proposal to extend the HPA by introducing the new external metric type for autoscaling based on metrics coming from outside of the cluster. So, this allows to use metric adapters that serve a variety of metrics from external services and make them available for autoscaling inside the cluster. External metrics are, and just a bit of a short description, they are metrics that represent the state of an application or a service that is running outside of the Kubernetes cluster. However, there is one big problem or caveat to this. There is a limitation in Kubernetes where you can only have one running metric server serving external metrics per cluster. And the reason for this is that only one API service can be registered to handle external metrics. So this means we'll have to choose which metric server to run and serve metrics, but which one? So this is where KEDA comes in. So KEDA, as I mentioned earlier, is a Kubernetes event-driven autoscaling. Essentially, it's a way to autoscale your workload based on events. So it gives you the ability to scale from events both inside and outside the cluster from a wide range of sources called scalers. They call them scalers. I'll talk more about scalers in detail later. So KEDA works alongside standard Kubernetes components like the HPA and can extend their functionality without overwriting them. So it can scale different types of Kubernetes workloads such as deployments, stateful sets, and jobs. It even has support for scaling custom resources. Now, one of its best features that I really love is that it can also scale a deployment to and from zero by activating or deactivating it. This hasn't been done before. So, yeah, KEDA is great with this.
Yeah, that's really interesting. So let's talk about bit deep about KEDA. How does KEDA work?
Yeah, sounds good. KEDA, you run KEDA as an application in your cluster. So when you set up KEDA, it will install two deployments called the KEDA operator and the KEDA metrics API server. The KEDA operator performs the key role as an agent or controller that sets the number of desired replicas. So how does it do this? It does this by creating and managing an application's horizontal pod autoscaler. So what I mentioned earlier, KEDA does not override HPA, but it uses HPA under the hood. So other roles by the KEDA operator is that it also registers and manages the KEDA custom resource definitions, such as scaled objects. So for the other deployment, the KEDA operator metric server, it performs the role as a metric server exposing the metrics to trigger the scale out. So KEDA primarily serves metrics for the metric sources outside of the Kubernetes cluster. So it uses external metrics and register that in the API service. So just to summarize, this will be the simpler workflow for KEDA. KEDA will keep an eye on event sources as messages in a queue, and then trigger the auto scaling of a deployment, and then the deployment will start processing the messages.
So this could be a good method, especially if you want to save a lot of cost, right? For example, let's talk about a booking platform. If you're having a football match and you're setting up a queue to queue your users, and when the queue is hitting by more users to the website or the platform, the e-commerce platform, so this could keep an eye on the queue, and depends on that, it can scale the workloads,
Yeah,
right?
absolutely. So it's pretty much scaling like a serverless, like Lambda, but you're scaling inside your clusters.
Cool. That's nice. So we are talking about a lot of metrics now here, Carlo. So let's talk about some of the supported metrics by KEDA.
Yeah, sounds good. Before we start, KEDA stands for event-driven autoscaling. So what are events anyway? So events are a bit hard to define, but we can define them as any change in a system. So this can be a pod restart, a configuration change, a database entry, or a lag on a stream, or any even of the trinity of observability, logs, metrics, or traces. KEDA has a very wide range of readily available scalars from different sources of events. As of the recording of this podcast, I think there are 64 scalars to be exact when I checked last their website. So it has scalars for queues and various event topics. It has scalars for streaming for services like Apache Kafka, AWS Kinesis, DynamoDB streams, and Redis streams. There are scalars based on database queries as well, from popular databases such as MySQL, MSSQL, CouchDB, or even DynamoDB. It even has support for the Kubernetes internal database, the etcd, which is amazing. There are also scalars for different cloud providers monitoring services such as CloudWatch for AWS, Monitor for Azure or Google Stackdriver, and even New Relic. KEDA has support for the use of CPU and memory utilization as well as cron job-based autoscaling. I'd strongly recommend visiting their website just to get a view of the full list of available scalars. And even if you don't find one that suits your needs, what's great with KEDA is that it's extensible. This means you can create or build your own scalar.
Oh, that's really cool. But to understand, especially for our audience, I think it's really good to give a use case or real time example where we can reduce the cloud cost by using KEDA or doing the scaling in our Kubernetes clusters. For example, it can be EKS, it can be GKE or AKS, or even your hosted own Kubernetes clusters. So let's talk about some examples. That would be nice,
Yeah,
right?
that would be great. It's the best way to show how the power of guys
Yeah,
to be taking with examples, especially
yeah.
in real time, a real world application. Yeah, one of the best way to maximize or leverage KEDA or the concept of the scaling is for cost reduction, like you mentioned. So cost reduction or optimization has been a major direction for a lot of companies given the current economic conditions. And one tool that can help you with this, as I mentioned, is auto scaling. That is ensuring you only provision what you need at any given time. So I'll share an example on how we maximize this capability to reduce costs. As we know, we practice GitOps in our Kubernetes clusters. And if you're not familiar with GitOps, it's just simply a way to use Git pull requests to verify and deploy your infrastructure as code. GitOps works well with Kubernetes owing both to their declarative nature. So we also use Terraform to write our infrastructure code. And we run our Terraform with a tool called Atlantis. Now, if you haven't heard of Atlantis, it's simply an application for automating Terraform via pull requests. As part of our platform services offering, we offer a self-service capability for creating new Atlantis instances to our developers. We call this product Atlantis as a service, or as for short. This service has grown in popularity with the number of Atlantis instances steadily increasing over time. This is awesome. However, alongside the increase in the service adoption, over the last year, we have also observed the cost has steadily increased every month. So by default, an Atlantis application runs 24/7. It constantly keeps an eye on a webhook request and responds to them. So where this request comes from? They come from developers who typically works 8 hours a day. So this means the rest of the day where developers are not working, Atlantis is running but not used and thus waiting a lot of resources. This idle time also does not even include weekends, which should be. So in short, we wanted to scale an Atlantis pods were not in use. And this is where we use KEDA. Apart from all the scalars that I mentioned earlier, there is another scalar that is out there maintained by the community and unofficially by KEDA maintainers. This is called the HTTP add-on. Now, the KEDA HTTP add-on, what allows you to do is that it gives you the ability to automatically scale your workload based on incoming HTTP traffic. Now, I just want to emphasize this one. The HTTP add-on scaler is not yet GA and still in beta. So the maintainers can still recommend it for production and provide it as is without support. So we've accepted this risk, especially since AS or Atlantis as a service is only internal tooling for our developers. First, what we did is we converted Atlantis instance to Kubernetes deployments from stateful sets which they run as default to it. Currently, HTTP add-on only supports deployments. That's why we have to do that. So we had to get a little bit creative working around some Kubernetes namespaces, networking limitation, which wasn't that hard really. And after that, we did testing and then we rolled it out and we had no issues. So far, just looking at kube cost, this has saved us around 6 to 7,000 US dollars a month. That would be around 85,000 a year, which was great. It made the bosses really happy.
That's a really good example because you're talking about some metrics like 5 to 6,000 USD is a big number, right? When you talk about per year.
Yes.
Yeah, definitely. I'm sure bosses are really happy about this cost.
Yeah.
Yeah, Carlo, I've really enjoyed the session today with you and so many new things that we shared with our audience today. I'm really hope everyone enjoyed this today, and those who are really interested later on, I'll be sharing a lot of links and they can go and try it out. And yes, Carlo, thank you for your time. And any suggestions before we ending this session that you want to tell our audience?
Go and try it out. I think Zach will be sharing some links later or after this podcast. So go and try out KEDA and see how powerful it is. And yeah, thanks for having me and thanks for listening.
Oh, thanks, Carlo. I hope to see you back in another one of the episode, Carlo,
Yeah,
in the
yeah,
future.
sure thing.
Yeah. Thank you for your
Thank
time.
you.
Have a great day. Thank you, Carlo, for joining me today. If you'd like to read blog post of Carlo and more about KEDA, please check the links in the description. I look forward to see you again with another episode of DevOps with Zach. Goodbye.